What's up guys, welcome back to another video, and we'll be covering the units of AP Physics C Mechanics, and I'm probably be following the course guide given by College Board. So unit 1, which is this video, will be Kinematics, unit 2 will be Newton's laws, unit 3 is work, energy, and power, unit 4 is system of particles and linear momentum, unit 5 is rotation, Unit 6 is oscillations, and Unit 7 is gravitation. Okay, so today we'll be only doing kinematics, which on the AP exam covers about 14 to 20% of the exam, so it's pretty important. And so I'll be using my teacher's notes as well as my own to help you out a little bit. So let's get started. So I'll be taking down notes. You can take down these notes as well. They're pretty helpful. I use them when I study for my AP exam. And so it's lesson 1, kinematics. That's so. Sorry if I'm writing small. Try to zoom in. So we'll start off with definitions and concepts. Okay, so kinematics itself is the mathematical description of the motion of an object through like equations and stuff. Let me write that down. Okay, so there are really 1, 2, 3, 4, 5, 6. Yeah, there are really just some things you need to know before getting to the whole meat of the process. So we'll be assigning variables and what they're called. So x in this case in kinematics is representing distance, displacement, and coordinate. And coordinates. X is generally used for stuff like this, but displacement is x with the bar or an arrow, I think. An arrow? Yeah. Distance is d and all that stuff. Yeah, so the difference between displacement and distance is that displacement is a vector, so direction matters. So if the guy travels from, let's say, 0 meters, right, to 50 meters, and then travels back to his initial position, the displacement of that man is 0 meters. While as if it's distance, it's a scalar, so direction does not matter. So let's say a guy travels 50 meters that way and travels 50 meters back. Displacement would have been 0, but in this case, distance would be 100 meters because you want to travel this to this and this back to this. So that's basically the difference between those. And next we have velocity, v for velocity, and it is a vector describing the rate of displacement. It can be found, the average velocity can be found as a change in displacement over time. So that's that. And it can be also found by using the derivative of x over time, like that. dx dt. If you give you a formula, like in the form of x and distance-wise, you can derive that formula to get the formula of velocity. That's basically what it is. So we have acceleration, which is the rate of change in velocity. And it could be commonly denoted. Average velocity is the change in velocity. Average acceleration is the change in velocity over time. It can also be noted that acceleration can be found as a derivative of v over t, dv over dt. and it is the double derivative of the x. So what this means is basically, if you're given an x formula, right, and it's in displacement, and you want, let's say the problem says find the equation for acceleration, and then it gives you a displacement formula, right? So you double derive that formula. You derive it once, and you derive it again, and that would be your acceleration formula. On the other hand, you can have a velocity equation, and you just derive that one, and that's basically it. It's pretty simple. It's really hard. So we're going to be reviewing the concepts of speeding up and slowing down. Okay, so let me draw an example. Say this is t and this is v. 0, 1, 2, 3, 4, 5, 6. And 6, 4, 2. Oh. -2, -4, -6. And as you can see, since acceleration is the change of velocity, a equals -2 meters per second squared, right? So that means velocity is changing at a rate of 2, -2. And so things to note here is, if acceleration and velocity share the same sign, it means it's speeding up. And if a and v are opposite signs, it means that it's slowing down. Okay? So you can also have increasing a's and decreasing a's. So let's say t versus v, 0, 1, 2, 3, and 4. And we have this 1, 3, 6, 10, 15. That's v. So in this case, you note that acceleration in this case is increasing, because the rate of change between velocities is increasing. So like that. And on the other hand, this is decreasing. Oops. Oh, you get the point. It just decreases, right? You can see this by the velocity side. See, take for example 0, 1, 3, 6, 10, 15. This increases by 1, this increases by 2, this increases by 3. So that means the acceleration is increasing, right? And it's decreasing when the rate of change of velocity also decreases. So it's like 0 to 10, which is the 10 difference, is acceleration. 10 to 18, 8. And so the rate of change gets smaller. Okay, so something really important here. I recommend that you memorize these formulas. Equations, because you'll probably be using them quite a lot, and I don't think they give it to you on like a reference sheet. So the most common kinematic equation, I'll explain them after. So x equals x0 or x naught, which means initial, plus v0t plus 1/2 at squared. So x final, x initial, velocity initial time 1/2 acceleration time squared. So that's one of the formulas. You also have v equals v0 plus at, which is final velocity, initial velocity, acceleration times time. And we also have v squared equals v naught squared plus 2a change of x. And basically final velocity squared, initial velocity squared, plus 2 times a acceleration times the displacement. So generally, these formulas are used in equations that have constant acceleration, constant a for those conditions. Okay, and conditionally, in the equations Basically, the best way to explain this is assign each measurement given into the variables. Like, let's say you're given an initial position, final position, assign them to these variables, write them out on the list, and then you can determine which formula to use, which equation to use based on what variables are given and what are not. So I think it's pretty easy. It shouldn't be much of a problem for you guys. But yeah. And if it is a non-constant a, basically just take the integral. And whatever, that's the same thing. Okay. So next, we'll be going over like different like conditions, I guess, or different like types of equations. Because a little tip for me is that generally most of the kinematics questions, they all are based around like certain types of like different types of motion, kind of. So like there are free fall problems, there are cliff launch problems, and there are ground launch problems, and always you repeat the same process, like repetitive, and you have to use like the same formulas every time. And basically you just have to memorize how to identify the conditions and what equations to use. So you probably get more experience as you do more equations and problems. But first, we got free fall. There are conditions that you have to know, and so I draw them out. So like, let's say there's an object being thrown, it goes all the way up and then goes all the way back down. All right. So the conditions that you need to know is that it's positive velocity. I usually denote as positive velocity initial and negative velocity initial. These are equal. And the time it takes to go up equals the time it takes to go down. And so the total time, which you would probably use most, is 1/2 total, which equals 1/2 the total time. So if you want to find, basically, it's kind of confusing, but basically, if you want to find total time, right, you have to add the time it takes to go up and the time it takes to go down. And these two are equal. So, and another thing to note is the acceleration going up equals the acceleration going down equals the acceleration at the top. Well, gravitational acceleration, right? So it's always negative 9.8 meters per second squared. It can be negative 10. It's personal preference, really, but I think the AP exam should be a little more specific. So 9.8, I think, is a specific measurement for that. So I'll write that out for you guys. A up. Can't see, sorry. A down equals A top, which equals negative 9.8 meters per second squared. And so basically, acceleration never stops or never changes as it goes up and as it goes down. So an example of a type of problem you might get is that the problem asks you to launch a ball up. Let's say launch ball up 15 meters per second. How high would it reach? Whatever, how high would it reach? And so, pretty simple, really. Sorry, got that organized. Oh, something I forgot, sorry. That at the peak of the motion, like when an object is thrown up and then it falls back down, the peak of the trajectory, like the top uppermost part, the velocity is 0. Okay, so I'll be needing that. So basically, we'll be using this formula, because these variables are only the ones that I have at hand. So final velocity is 0, right? Because it reaches the top, right? Equals 0. Initial velocity is 15, as given, plus 2, negative 9.8, and change of x, like that, like so. And so when you solve for the change of x, you're basically solving for when the object, or how high the object goes for in this initial half. So it's thrown, right? and you solve for this height. That's how you solve it, like that, right? You want to use the negative v naught because that would make sense, and the displacement would probably be 0. So, and solve it out. I'm not gonna do it, but solve it out for h. I just use it interchangeably, but you can just keep it as displacement. So once again, this is a free fall problem. I'll go over the concepts once more. So a guy throws a ball up at initial velocity, and it equals the negative velocity. So these two are equal, but this one's negative, this one's positive, because remember, velocity is a vector, right? So direction matters. And at the peak of the trajectory, velocity equals 0, and the time it takes to go up is also equal to the time it takes to go down. And in order to find time total, you have to add the time it takes to go up and the time it takes to go down. And acceleration due to gravity is always the same, no matter what point of the trajectory or the peak, and it's always negative 9.8 in my case. You could use 10 for simple purposes, but I like to use 9.8. Okay, so next I'll be going over briefly like different types of kinematics graphs. So I'll just write out graphs, right? And I'm thinking of a way to present this to you guys. Simply. Yeah, okay, I'll write it out in like a little table. So let's say you have x, or distance, versus time, right? I'll write out the different cases, velocity versus time, because remember you can have different types of graphs, right? And acceleration is time, right? So it turns out that you can use the graphs and use them to find like different measurements. So generally, what you can find out: slope, area, y-intercept, x-intercept, right? So for a x, or distance versus time, the slope of such would be velocity, right? And the area would not give you anything, and the y-intercept is the initial position of the object, and the x-intercept is just x equals 0, right? The slope of the velocity versus time is acceleration. The area of such is displacement. Initial v equals 0, and I'll just write it out. It's pretty easy. Initial a and a equals 0. So these different types of graphs have different measurements sometimes, and you can find them out. So I don't know. So basically, you wanna know like what you can find from different type of graphs, right? The slope, area, y-intercept, x-intercept. Another thing to note is uniform velocity and uniform acceleration and the graphs and such. Trying to think of how to illustrate these. Okay, so uniform velocity. So velocity is constant. It stays the same number. So acceleration as the rate of change of velocity would be 0, okay? So if you want to, generally the graphs would be like kind of like this. And they're like two different cases. I'll show you. So the straight line, this one, is the case that the object is going forward and is going fast, right? And the dotted line is when the object is going backwards and is going slow, okay? And I'll just draw it out. Remember, the dotted line is going backwards and slow. The straight line without any dots is forward and fast. velocity versus time, and A versus T. This is unique because A is 0. So the graph of A versus T would be 0. So it's always like this, both of them. Okay. And uniform acceleration is when the acceleration is constant, right? So X versus T will be like this: forward fast, backward slow. Because if you think about it conceptually, it would appear to be such, right? Velocity versus time, like that, and like that, right? And acceleration, the acceleration graph, both of them are here because they're constant. That's basically it. Remember to recognize these types of graphs, right? But I don't think they'll be too important. I haven't seen many like this, but it's still good to know, right? And for the AP exam, I think in order to get a 5, you have to just get like 63% correct. I'm not too sure, not certain, but it certainly is doable. And don't fret out on the small stuff, but focus on like the main concepts. But if you haven't learned this stuff yet, then just do the best you can. And another case is projectile motion, right? When F net equals Fg. And the acceleration to x is 0, always. And the acceleration to y is negative 9.8. Right. So, yeah, okay. And there's 2 different types: cliff launch / plane drop. And there's a ground launch. So, commonly you see these a lot. Like that. And there's like a little drop point, right? It's height, displacement, and initial velocity. So the common method for this is to solve it in 2 directions, right? You split it up. So you split it in the x direction, you split it in y. So the y direction in physics is noted as a j hat, right? And the x is I hat, right? So in the j hat direction, h equals 1/2 gt squared, right? Because how do I explain this? Because basically the velocity will not exist, right? So I don't know how to explain this to you guys, but basically I think we'll be using this general formula from before, right? But in this case, since it's in the j hat direction, right, you can cross these out, and you just want to find height equals 1/2 at squared. I'm sorry if I can't explain this very well. It's very hard to explain this. I don't know. I don't know that well. And x equals 0, 0 t for the x direction, right? Man. I'm trying to think of a way to explain this easier to you guys, but I don't really know. It just like clicks. I think your teachers would probably explain it better than I. Man, yeah, so I'm sorry if I can't explain this very well, but all you need to know is that you can solve cliff launch problems by basically solving for one direction, which is x, and solving for y, right? You just find a common variable between these two and solve for it. So like, commonly you can see problems like solving for t, like the time it takes to fall such distance, right? And that'll be the same as this t, the time it takes, because remember the projectile or the object shares the same time, right? It can't be different in 2 different directions, because that obviously would not make sense. So, and there's another one, ground launch, And basically I'm just gonna write it out. I think you should just memorize this or a type of such. I don't know. And this is a force component, right? And you should probably v cos theta, v sine theta, and it just drops like that. Someone launches and it drops. So in the j hat direction, v equals v0 plus at, and then negative vy equals positive vy minus gt, right? Solve for t, you know, all that good stuff. You could also do h equals 1/2 at over 2 squared, because remember that the time it takes to go up is equal to time it takes to go down, and it's 1/2 time total, so t over 2, and x equals v0t. Okay, so I think that's it for kinematics. I'm sorry for not explaining this very well to you guys. I can't really explain this very well because it's been a little bit of time since I take this course, and I know I think it'll be better for you guys to learn in class, but I just did like a general review, I guess, to prepare you guys. You can always search out different videos on YouTube. I'm sure those will be better explaining than I have. So today, what we did, lesson 1, kinematics, that would be done. We learned the definition of concepts, the equations to use, different situations, the graphs, and so that is it. And remember, this is 14 to 20% of the exam, and it includes kinematics in 1 dimension and kinematics in 2 dimensions, and that's it. I think next week I'll be releasing a video. It'll be on Newton's laws of motion. Okay, that'll be unit 2, and it is approximately 17 to 23% of the AP exam. Okay, and that's it. Yeah, I think that'll be it. Yeah, so thank you for watching in, and stay safe, everyone. Wear your masks. I'll see you next week. Okay, we'll be doing Newton's laws. Sorry for not explaining that well. I'm not very good at explaining these types of things, but thank you for watching nonetheless. So see you.